Okay, gentlemen. Now, I'm sorry that this is taking longer than one video. But again, if you want to find the value of x, you find the value of the opposite of b over 2a. And we get those values from the equation itself. A, B, and C. Okay? Now, let me clear up this stuff. Okay? And keep moving on. Now, David said if we want to find the y, we'll just plug in what we got for x into the equation. It'll give us the y. Then we have the vertex. Okay? Now, number 2 says choose two more x values equal distance from the vertex. Let's just say that our vertex was 1, -3. Let's just say that that was true. What would be two x values that I could plug in on either side of the vertex that are the same distance from it? Well, let me ask you this. What if I plugged in 4 for this point? What would the x be on the other point? Eric?
0.
Not 0. Not 0. Ben?
-4.
Not -4. No. Ian?
-3.
Not -3. Arjun?
-2.
-2. Why -2? Well, think about this. From 1 to 4 is +3. From 1 to -2 is -3. They're the same distance from the vertex along the x. Do you understand what I'm saying? So then, to find these other 2 points, you plug in these values and find their y's. So 2 says, choose 2 more x values equal distance from the vertex on each side and plug into the equation to find 2 more points to show how wide the parabola is. Okay. Number 3 says if a is positive, like in this equation, that's 1x squared, so the a is 1, and that's positive. If a is positive, your graph should be opening upward. If a is negative, your graph should be turning down. So number 3 is just to check and see if you've got it right. Okay? And then number 4 says the axis of symmetry is the equation of the vertical line going through the vertex. So there's a line. You see a parabola is symmetrical. You can cut it in half with a vertical line. And if you write the equation, x equals 1 to that line, that thing is called the axis of symmetry. What you're saying is this parabola is symmetrical around this line. Okay? All right. That's a lot of stuff. Let's try and graph this thing. Okay? Let me erase all of this mess so that we can actually get some work done. All right? I'm going to expand this a little bit, give myself some room. The equation is h of x is equal to x squared minus 2x minus 2. A equals 1. B equals -2. C equals -2. I won't need C for this. The first thing I'm doing is finding the vertex. Okay? All right? So, okay, it's the coefficients, right? A, B, and C. Okay? Just like I would plug them into the quadratic formula. All right. I'm looking for the vertex. The x-coordinate of the vertex is -b over 2a. So now I'm going to write parentheses and plug in the right values. B is -2. So, Joe, that's going to make it turn back positive, right? And then a is 1. So this is going to, when it simplifies, that's going to give me 2 over 2, which is equal to 1. So the x-coordinate of the vertex is 1. We're going to need 3 videos, aren't we, Reed?
Yes.
Okay. First time ever. Okay. So now we found out what x is. To find out what the y-coordinate of the vertex is, I just plug it in, right, Alexander? So h of 1 is equal to 1 squared minus 2 times 1 minus 2. Okay, h of 1 is equal to 1 minus 2 minus 2. H of 1 is equal to, what is that, -3?
Yeah.
So that's my vertex. I'm going to erase this just to give us some room here. So that's where the graph, that's its minimum point in this case. So 1, -3 goes right here. Okay?